Hey everybody, Mr. Calbeck here. I've heard lots of questions on this. Nothing specific though. Remember my rule for questions is it needs to be specific so I can actually help you. Unfortunately, I haven't gotten any good specific questions other than I don't get it, Calbeck. If you're one of those that is an I don't get it, Calbeck, please think about specific questions for the rest of the year. It's really helpful for me. Um, but we're going to talk about question 2 from the homework on the quadratic applications. And we're going to talk about how to find all the different pieces. I've drawn a little diagram here, which might be helpful for some of you to see because you don't like to draw diagrams for some reason. Please always draw a diagram if you can. It's so helpful in every situation that you could possibly draw a diagram. Draw a diagram. It makes everything so much easier. The second thing I want to encourage you, I haven't taught you any new math since the quadratic formula. So it's really important to not overcomplicate things. It's not like you have to learn a new thing every time that there's a new lesson. What we're doing here is we're applying things that we already know. So don't sit there and just panic and try to come up with something new. Use what you already have, what you already know. Break it down. In fact, all of this actually comes back to our linear unit because it's the same kind of questions. It just has an x squared term in it. So there's one more step, but all of this stuff is the same thinking that we did in the linear unit. When you tried to figure out things like how fast your tricycle is going, or at what point did your tricycle pass another tricycle? All those kinds of silly questions we did back then. This is the same thing. It's just a different equation. So try not to panic as you're doing these problems. Think about it carefully. Think about it slowly. Think about the resources that you already have. All right. So let's talk about this problem here. So this is modeled by the equation h of t equals negative 16 t squared plus 64t plus 80. Okay, so that's the equation of the rocket here in this situation number 2. It explodes at the peak and then kind of plummets back to Earth. Couple of quick things on this. Remember, this is the same as y, so don't panic. That's the same thing since we did the month into school. We talked about function notation is just y. It tells us a little bit more information. This is a y variable that depends on the variable t in order to make it work. It's also used h to represent, it's talking about height over time. Okay, remember the negative 16, that's a variable that represents the gravitational constant of Earth, so that's never going to change. It's always going to be negative 16, so long as you're talking about feet in seconds. Feet in seconds is always going to be negative 16. The t's are all seconds, so don't forget that. Those are seconds. 64 is the initial velocity, so the starting amount of speed, which actually doesn't matter in this problem. So but we do call it v sub 0 to represent the initial velocity, and 80 is the initial height. We call it h0 for initial height. So again, I could, without even looking at the problem, I could tell that this hill is 80 feet tall because it's the initial height from where it was launched. Okay, so that's just a basic overview. So if it asked me the height of the rocket after 1.5 seconds, that's question A. What that's really asking here is it's saying, okay, what is the y value? Because y is height when t is 1.5. So all I'm doing for question A is I'm saying, what is h of 1.5? So that means all I need to do is every time I see the equation, I just replace t with 1.5. Nothing too fancy about that here. All right, and you guys can type that into your calculators. Again, when you're typing them in, a lot of you are trying to just take shortcuts. Remember, be careful. You want to use the negative button and not the minus button at the bottom here. So when I type negative 16, you use this button right here, or you'll get an error. So negative 16, use your parentheses. Use them liberally. You guys can go ahead and type this in. And you hit there. So what that tells me, again, I'm asking for height after seconds. So this is 140, and the height is in feet. Remember, height is in feet. So h of 1.5 is just equal to 140 feet. If you have units, use them, please. Okay, and that's all you have to do. All right, question B, the maximum height reached by the rocket. Remember, it explodes at its maximum height. In a parabola, the maximum height is going to be the vertex. Okay, so all we're asked to do in this problem is find the vertex, and that's literally the same thing we've done since, we've been doing this for 7 weeks now. You had a test before quarantine about finding the vertex, and you can actually use the exact same process here. This is a factorable equation. Since it's factorable, you can factor it, find the x-intercepts. Right in between is the vertex. I have since taught you a faster way to do it by using the quadratic formula. Remember, the quadratic formula has that little piece at the beginning where x equals negative b over 2a, and that's the line of symmetry. Remember, in every parabola, there's a line of symmetry, and the vertex falls on the line of symmetry. And since this is the x-coordinate, that's just, once I find x, I can plug it in to find y. And this gives me the x-coordinate of the vertex. So I can plug that in. Remember the a, b, and c piece. The first one is a, so that's a right here, negative 16. B is positive 64, and C is 80. And again, we've actually talked about that for longer than 7 weeks because I talked to you guys about polynomials, and we did standard form of polynomials, and I gave you a whole big equation, but every polynomial can be written the same way. ax squared plus bx plus c. So the number next to x squared is always a, number next to x is always b, number by itself is always c. And you can add more and more variables if you need to. If there's a cubic term and a is still next to the cubic term, b would be squared, c would be x. You'd have a d and e. It doesn't matter how many you want. Okay, so I'm going to plug that in. B was 64, so that's negative 64 over 2a, which is 2 times negative 16. All right, and so that's negative 64 divided by negative 32, and you could do that in your head, I hope. That equals positive 2 because it's a negative divided by a negative equals a positive. So the maximum height occurs 2 seconds after lunch, which means all I'm looking for here, I want to find the height of this after 2 seconds. So instead of h of t, I want to find h of 2. It's the same thing. What is the height when I have 2 seconds? And again, we're going to do the exact same thing. I can show you a quick shortcut here. Since I've already typed all of this in, you can hit second enter. Second button on enter says entry. And if you hit it, it brings up exactly what you typed before. And you can just replace what you had in the previous one. So instead of 1.5, you can hit 2. And then just use the delete button to get rid of the rest. So you don't have to type the whole thing in again, which is kind of nice. I'm going to type this, replace that with a 2, delete the rest, hit enter. So it's going to have a maximum height of 144 feet. Okay, and again, that would be the vertex location. So my vertex would be at 144. And just because I switched x to t and y to h of t, that doesn't matter. They still mean the same thing. They still go in the same place. There's still x and y coordinates. So again, try not to complicate this. You already have all of the pieces. We have done every single piece of this before break. In fact, I would have expected you to be able to do this exact problem before we left for break because you can factor this. That's a factorable question. Okay, so if you factor it, you can find the x-intercepts, which means you can find the vertex. So there's not anything new here. All I've done is taught you a faster way to do the exact same problems we've done before. Okay, the next question, C. Let me grab a new piece of paper here. It says, how do we find, how long will it take the rocket to reach 128 feet in the air? This one's a little trickier. So let's go back to our question, our equation. So it's h of t equals negative 16t squared plus 64 blah, 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 blah. All right. And again, I always use a cursive t so it doesn't look just like the plus signs. Great idea for you guys if you're getting tripped up. That might be a little place you're making small mistakes. So here it's asking me, okay, when or how long does it take for it to reach 128 feet in the air. So if I were asking that question, I'd say, okay, what does it mean when I say how long? What is that actually asking? That question is asking for t. It says, what is the t, or the time, right? I want to know what the t is. So the question is, what does it give you? I'm supposed to be finding what t is. It tells me the height, and the height is represented by h of t. So all I need to do is replace h of t with the height, and we've done this 100 times in class. I know it looks a little different, a little scary, but I promise you guys you already know how to do this. Okay, so try not to panic. I know it's hard to do it over break, but a big trick you can do is to take out the headphones, turn the TV off, and put your phone away, because that'll be super distracting, and it's easy to get tripped up on this stuff. When you're using your phone, trying to do this math at the same time, multitasking in your brain actually makes you think at the same level of an 8-year-old. So you're trying to solve this with an 8-year-old's brain. Can you imagine trying to do this in 3rd grade, 2nd grade? This would be really, really hard. For an Algebra 1, 13, 14, 15-year-old student, this is much more capable, okay? You got a lot more horsepower to do this, but you can't do this with an 8-year-old brain. So turn off the distractions. Okay, so h of t, I'm just going to replace h of t with the height, because that's what they gave me. They told me this is 128. So I'm just replacing all of h of t with 128, and then I have to solve for t. All right, this looks a little bit more familiar, but it's still a little bit unusual. So we got to figure out how to do this one. So I'm going to say, okay, how do I solve things? Okay, I've got an x squared or t squared, a t and a number. So I need to be thinking either factoring or quadratic formula. But remember, before you do either one of those, you have to have 0 on one side. And I don't have 0 right now. So if I don't like the way something looks, change it. All right, so I'm going to subtract 128. 128. Now I have 0 over here, and now I can do whatever I want with this problem. 16t squared plus 64t, and then these subtracted, that's going to give me, sorry, I can't do the math right now, 64t minus 48. Okay, let me just redo that. That kind of looks like it. 64t minus 48. Now this problem right here, you can choose to factor it or use the quadratic formula. These numbers are pretty big and annoying, but as it turns out, this thing all divides by 16. If you would like to factor it, you totally could. Everything's divisible by 16, and I'm actually going to make it a negative 16. So you could do negative 16 times t squared, because I divided it out. 64 divided by 16 is 4, and I'm going to make it negative since I divided by a negative. 48 divided by a negative, that's going to be a positive 3. This is a super easy question to factor if you want to do it. It's t minus 3 and t minus 1. I want to know where that equals 0. You can solve it. Remember, you can get rid of this 16 because I'm asking, I have 3 things multiplied together that make 0. This one is 16, it's not 0. That means the 0 has to come from one of these two. So you can just ignore that 16 that you factored it out. So 0 equals t minus 3 and 0 equals t minus 1, and solve. Add 3, add 1. So I get t equals 3 seconds and t equals 1 seconds, which, I mean, does it make sense for us to have 2 answers here? When does it reach 128 seconds? And it does make sense if we look at the diagram, which again, a lot of you aren't doing, which makes it more confusing. So draw a diagram. I reached 128 feet right here after 1 second. But then it keeps going up, and then guess what? It comes back down to 128 feet after 3 seconds. Okay, which is why you get two places, because it's going up and then coming back down. It's going to reach the same height twice. Okay, now you could have done this exact same problem if you wanted without factoring, but factoring is always faster. It's always easier. Quadratic formula, though, is a great fallback. It's a bazooka. It solves any problem. But in this one, it was overkill. But you can still do it. Once you get 0 here, you can use the quadratic formula on this exact same problem if it's tricky. And solve it. You can do negative b, x equals negative b plus or minus the square root b squared minus 4ac all over 2a, right? But this case b is negative 60 or 64, so it's negative 64 times 64 squared minus 4 times a times c all over 2a. You could do all that problem, and that will give you two answers as well. If you do all of it, it will give you 1 and 3. If you don't get 1 and 3, you did something wrong, and I guarantee it's a negative if you made a mistake. Okay, you get the exact same answers, and it tells you the same things. Okay, you don't, and again, don't feel bad if you did the quadratic formula. Don't feel bad if you like to do easy math and you wanted to factor it instead. That's fine. Always a great idea to check to see if it factors, because it costs you about 30 seconds to check to see if it factors versus the 4 minutes of math it takes to do this. It doesn't really cost you a lot of time, and it can save you a lot of time. Okay. Last question here is how many seconds before it hits the lake. So I want to know, where does this crumpled, do you like my crumpled rocket? I think it's pretty good. Where does the crumpled rocket smash into, this is my awesome drawing. Okay, you can draw a really helpful diagram without being a good artist, for the record. Okay, so when does it splash into the lake? And all we need to do there is take the original equation. Okay, we're going to take the original equation again, but this time I want to know when this equals 0, because 0 is going to be the height that I'm looking for. And since it already equals 0, you can plug all of that in. Let's do the quadratic formula this time, because that's another way to solve the same problem. So 0 equals 16t squared plus 64t plus 80. And we just do the quadratic formula with this. So negative 64 plus or minus, because this is b, minus 64 squared minus 4 times a times c all over 2a. And this is going to be a huge number at first, but it's going to simplify down really nicely, I think, for you. So let's go ahead and try this. I always start with the square root. So I'm going to do 64 squared, which is 4,096. Goodness gracious. And then I have 4 times 16 times 80. I know this is going to end up as a positive number since I have two negatives. So it's going to be plus all of this. And all those multiplied together gives you 5120. I'm going to take the square root of both of those, add it together. And all of this square rooted is going to be equal to 96. Again, it comes out really nice and even. That's a good sign. If it ever comes out even like this, that probably means it factored. Actually, it does mean it factored. So if you get a whole number, you're like, gosh dang it, I did extra work. That's okay though, because we're already halfway through it, even though this one of it have factored as well. 2 times negative 16 is negative 32. And we're just going to do two problems here. We're going to do negative 64 plus 96 divided by negative 32. Remember, that's in parentheses. And we're going to do negative 64 minus 96 all over negative 32. So we can, again, remember the numerators need to be in parentheses. So negative 64 plus 96. That's 32. So I have 32 divided by negative 32, which gives me negative 1. And we need to ask ourselves if that makes any sense. And then this other one here, I have 64 and 96. That's 160 divided by negative 32, which equals exactly positive 5. So the question is, do both of these numbers make sense? Remember, we're finding t or x in this case. So if we look at our problem here, we're trying to figure out where the height is 0. Since I started on the top of the hill, I actually didn't start at 0. So I would have to go backward in time 1 second to get to 0 height. So this negative 1t seconds doesn't really make sense since I started on the top of a hill. I didn't like dig a hole and go find where the height was 0. The only one that makes sense, the only one that we're really looking for, is where it hits the lake, and that seems to happen after 5 seconds. So there's your answer. Okay. I went into some pretty great detail here, but I do hope that's helpful. Your homework tonight was to find how to do systems of linear equations. I want to see how you guys do with the written directions instead of me walking you through it. I'll probably do an example problem later this week, but good luck with that. And again, please be specific as you can, and don't panic. You know how to do all this stuff. Plugging in, like, it's really just a question of, all right, am I plugging in something for y, or am I plugging in something for x? Those are the only two questions I can really give you. Everything else, I mean, that's literally the only kinds of questions I can give you. So every one of these problems here, what was the height after 1 second? I gave you the x. Find y. What's the maximum height? I said, well, I told you what the x was by giving you the line of symmetry. Plug it in, find y. The next two questions we did said, how long will it take for the rocket to get in the air? Well, that one, I just gave you a y value. Find the x, or the t, right? And the last one, I said, when does it hit the lake? That means the y value is 0. Okay, so when is the height 0? When is the y value 0? Find x. So it's literally, I can give you an x, I can give you y. That's all I can do. Those are the only two kinds of questions. And once you have all these tools, you can solve anything I can throw at you. All right, so best of luck to you guys. Please shoot me those questions. Hope things are well. By the way, thank you for all of you who are asking about how I was doing. I did get some food poisoning. I would not recommend Kroger brand bratwurst. It was not a good experience. Uh, anyway, I hope you guys have a great time. I hope you stay well, and I hope that I get to see you soon. Hopefully next year when class starts. Come say hi to your old dictator, okay?